Dear Success and Algorithm Lab, experiment number 10. So in this lab, we are asked to implement a hash table with with two hash uh, with two hash resolution techniques. Okay, so I'll just first show you the output and then I'll go on to the explanation. I used linear probing and quadratic probing in the hash resolution technique as the hash resolution techniques in this. So first I'll go to the output. So the first few lines are to show that this code belongs to me. And then we have the statement, hey user, enter the size of the hash table you want to use. So for this example, I use 10, but you can enter any size up to 10 power 5. That is the max limit of an integer. So, and then it's ask, enter the choice of hashing technique. First, I'll show you linear probing. Now, here there are three options you can choose, either to insert or search a node or to display. So, it's not search a node, just search. But then so search data. Okay, something like that. So first I'll insert few elements. Say I want to insert 69. Then I want to insert one more element, uh, 78. Okay, and now I want to insert one more element. Say an element that ends with 9, so that hash collision will occur. So say I wanted 89. We'll also have one more element. Okay. Before that, I'll just display the output. Okay. First, I enter uh, 69. So 69 mod 10 is 9. So it's in the 9th position. And then I enter 78. This mod 10 is 8. So it's in the 8th position. And then I entered 89. 89 is also in the 9th position. Hash collision occurs. So it goes to the next available space. That's here, and it fills that. And now I'll again insert one more element which also has a hash. I'll again insert one more element which also makes an hash collision, 79. So here, if you see now, it first checks if there is any element in that 9 position, hash collision occurs, and then it goes to the next available space. It's here. Again, there's one more element here, so it goes to the next available space. Here it was free, so it filled it. So this is how it works. And now let me show you searching. Say I want to search 79, which I enter. And if you see, position in hash table is 1. Yeah, it correctly show that it's in the first position. So this is right. So what if the list is exhausted, like hash table is full? So I'll just enter 79 again and again. Four more values. 99, 99. So one more. Again 17. This should do. And now, if you see, okay, if I insert the hash table, it should be full. If I insert, it should show an error. So say 78. See, it shows error hash table is full. So that edge case also works. And now let's go to quadratic probing. Before that, it's asking, uh, do you want to clear the hash table before leaving the memory? I type yes. It will initialize everything to -1. We clear everything. So that's there. Then quadratic probing. Now I'll insert 69. Then I'll insert 79. And then I'll insert 89. So if you see here, first it inserts 69 at the 9th position because 69 mod 10 is 9. And then when it inserts 79, hash collision occurs. So it 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 goes to the I square position. So initially here I was 0. Then for this I will be equal to 1. So we'll go to the first position. And then here this mod 10 is also 9. So it'll go to the respective I square. So for I value here will be 2. So 89 plus 4 mod 10. So it'll be 3. So it is placed in the third position. Okay. So this will be keep on going on. Now it's here because 89 plus 3 square 9, that'll be that will be 98, so it should be 8 questions there. So let's fill this. 99, 99, 99. Okay, at this case hash table is full. Okay, there's a small error here. Okay, at this case, reason for hash table to being full is after this you can't enter any elements. Okay, for 79, uh, say, wait a minute. Yeah, like with all the I values, uh, like up to n, that is up to 9, whatever you use, it won't be like it cannot be placed in any of this position. So that's why we get this error. This is a drawback of quadratic hashing. The drawback of quadratic program. So, but if I insert any other element, there are chances that will be inserted. It depends upon each element because it's an I square, right? So one, then it becomes 4, and then it becomes 9, 16. That element plus this I square value should lie uh, somewhere. Uh, okay, that element is I square value mod 10 that should actually be in any of the positions here. If it's not, then it won't work. So if I want to search or not, say I want to search 17, okay, I'll search 89 because there's only one thing. 89, so it shows me 89 is in position 3. If I want to search 69, so 69 is also, oh sorry, wrong input. Search 69. So yeah, okay, 69 is in position 9, so this also works. So let's go for the code. I'll start explaining now. So here I'll go through it quickly. So here first thing is clear. What this does is it initialize all values in the array to -1. Display it starts from I is equal to 0 up to the max size of the hash table, and it prints all the elements in the hash table. Linear insert and linear search are used in linear probing. In this, first we calculate the hash place. So hash place will be data mod n. Here there is no hash function. Like uh, it's just x mod n. There's no like special hash function. So for this, hash place will be data mod n. If the current hash place position is double equal to -1, then just update uh, that position with the data. Okay. Otherwise, what we do is we iterate from I is equal to 1 up to the n. This is last table. Here, I will be the element to be added here. So hash place will be data plus I mod n. So what this will do is this will go to the next available free space. So like that will go. And if that place is equal to -1, then it updates the place. Otherwise, if all are filled, then this error pops up, hash table is full. That's it. Then we go to linear search. Same code only. Only difference is here it will be like if array of hash place is double equal to -1. There, like there, there what we check is if array of hash place is double equal to the data we want to search. In that case, we just print the position. Otherwise, we go through all the elements do the same thing, data plus I mod n, and if if the current element is equal to the data we're searching, same thing will do. Only thing is here under -1 we have data, and here we have a statement to print the uh, position. If this fails, then there's this line stating the given data is not present in the hash table. Okay. Uh, this function is called. It actually calls all this function. Uh, like if you remember in the menu, as soon as you choose linear probing, as soon as you choose linear probing, this function is called. Okay. Uh, yeah. So here, here it just prints the menu as the choice until the choice is not equal to 4. 4 is exit. It will run. Then here I have switch case statement based on the user's input. We'll call it a respective function. Here, if you remember, we'll call if I give one, it'll ask user for data and call linear insert. If I give two, it'll ask user for data and call linear search. Uh, Third one, display, is the one I showed you at the start, and this is if the user gives any other element other than 1, 2, 3, 4, this line will be printed. Then again I print the menu and get the choice, and the control is here until the user gives 4. After the user gives 4, there's this statement is is being printed. If you want to, if you want to, if you want to, like it'll ask, do you want to clear the hash table or not? So if I give one, then it will perform this operation clear. Otherwise, we'll just go to the uh, otherwise it will just return the call to the calling statement. So this function quadratic insert is similar to linear insert and linear search. If here quadratic insert, quadratic search, quadratic solving are all same only. Only difference is there you had I, here you have I times I square. Same function built on it. Only difference is instead of I you have I square. That's the only difference. All is the same. Here instead of calling the linear insert function, you call the quadratic insert function. Same here. That's it. Same thing here. Okay. Now to the main function. This is to print the to show that this code belongs to me. That art that I showed in this thing. Which was this thing. So all those are all those are all those are all those are Unicodes. So that's it. Then here, I just ask the user to print the size of the hash table here, and I initialize the hash table array, and then make and then I call this function to make all the elements in this hash table array equal to -1. And after that, I just print the menu and ask the user for a choice. Based on a choice, the respective function will be called. So if the user gives 1, I use the switch case statement here. If the user gives 1, it will call linear program. If the if the user gives 2, it will call it will call it will call will call it will call quadratic program. And if the user gets 3, then it will exit. Then the program ends. If the user gives any other than 1 to 3, then this default signal will executed. And here I I again and I again print the menu, and then I get the choice until the user gets 3. This control will remain here. So that's all for this program. So and